Take a look at this simulation here. This is a little driver, and this thing is actually connected to this mass, and this is like a mass on a spring. Notice if I drive this with, say, I don't know, we'll try 1.5 second period, right? The resonant frequency of this thing is 2 seconds. So if this thing is not the resonant frequency, the driver's the mass's motion is, let's just say, complicated, right? It doesn't do a lot. It kind of wiggles around for a while. It'll eventually hit like some sort of equilibrium where it's kind of doing more or less the same thing. These are actually beats, which is sort of funny. Let's stop and reset it. If I get it really close to that, let's say we try 1.9. Remember, the resonant frequency is 2. This thing will, of course, do something more spectacular, right? It's like, whoa, gets a lot bigger. And then, of course, if I match the resonant frequency, if I type in a 2.0 there, this amplitude will get quite large. Now, it doesn't get infinitely large because this system has a little bit of damping, right? If it had no force taking energy out of the system, like for example, damping could be a mass moving through air or moving in oil or having like a shock absorber on it or something like that. If there's no damping, then of course, as we give it energy and it doesn't lose energy, it gets eventually infinite energy, which of course will take a long time, but there it is, right? So notice right now, it's building up energy. If we stop it and reset it, if I turn the damping off, this thing would just go up like that. Let's try that. So the concept of resonance is just simply that we're driving the system at the rate at which it wants to go. Look at this thing. This thing's just gonna go crazy. We're gonna break it. Look at it. It's going off the graph. She's going off the graph. We're just adding more and more energy to it every time. Whoa, baby. Ooh. All right, I'm going to stop that. That's crazy. All right, now take a look at this Barton's pendulums here, right? So 1.6 is the frequency we're driving it at. These other ones are different frequencies, or sorry, they're different periods, right? But the 1.6 is the one that's going to get the most excited by this, right? And I can, by changing the driving period, I can drive any one of these right here. Let's stop it, reset. If I type 1.8 in, right, then I'll get the 1.8 will go crazy. Watch. So now we're driving the 1.8. The 1.8 is going nuts. And I can change my period to 1. And I can make this left one go crazy. There we go. So that's the concept. If you match the frequency of the oscillator goes crazy.